Hello friends, welcome to my YouTube channel Physicscafe by Manjeet Kaur. In this video, we study about class 9th physics chapter sound. This is the last chapter of class 9th physics. Sound. In day-to-day life, it's impossible to imagine a world without it. It is probably the first thing we experience when we wake up in the morning, when we heard alarm clock blipping. Sound fill our days with excitement when we talk with our family, with our friends, listening music, hear interesting programs on TV and radio. So what is sound? Sound is a form of energy. According to law of conservation of energy, we know energy neither be created nor be destroyed, but it can convert from one form to another. So similarly, sound is the sensation we perceive when vibrations in the air are detected by our ears. Then ears convert these vibrations to electrical pulses. After that, these electrical pulses are transmitted to our brains by our nervous system. So, vibrations convert into electrical pulses because of law of conservation of energy. Energy is converted from one form to another. So, sound is just like electricity and light and can be heard by ear. Think of you when you clap your hand, the action produces sound, which can be heard by our ear. Here we have some examples of sound in day-to-day life. Now we have the definition of wave. A wave can be described as a disturbance that travels through a medium from one location to another location. That means energy transported from one location to another location, but the vibrating particle remain their main position. It no travel with the energy. To understand this, let's take an example. Here we have x-axis and this is y-axis. The wave moves from left to right and the particle is vibrated about its main position. So in this diagram, the energy is along x-axis but the particle is oscillated around its main position. Particle not move with energy's direction. Only energy is transported from one location to another location. And when energy is finished, then the particle will stop and remain its own position. The wave is of two types, mechanical waves and electromagnetic waves. Mechanical waves requires a medium in order to transport the energy from one location to another. That means mechanical waves has to have a requirement of medium. That medium can be solid, liquid and gas. Without any medium, the mechanical wave cannot travel from one location to another. The best example of mechanical wave is sound waves. Here we have example. When we play a guitar, it requires a medium to travel the energy from one location to another. So that medium which it requires, that is air. Now we have electromagnetic wave. Electromagnetic waves can travel not only through air and solid material but also through the vacuum of space. That means Without any medium, the electromagnetic wave travels from one location to another location. The best example of electromagnetic wave is light. Light can travel through vacuum. Here we have example. Ocean waves requires a medium to travel from one location to another location, that is water. Mechanical wave is of two types, transverse wave and longitudinal wave. Before we study about transverse wave and longitudinal wave, we first know the diagram of transverse wave and longitudinal wave. We first study about transverse wave. Here we have x-axis and this is y-axis. The wave moves from left to right and the wave is along x-axis. And the particle is vibrated along its mean position. That means the vibration of the particle is up and down about their mean position, and the movement of particle is perpendicular to the wave which moves horizontally. So, the maximum up from the mean position is called crest, and the maximum down from the mean position is called trough. Crest, which is also called elevation, and trough, which is also called depression. So, in a wave, we have 1, 2, 3 and so on, crest and trough. So, this is the diagram of transverse wave in which the vibration of particle is up and down about their mean position. Now we have longitudinal wave. We have x-axis and this is y. We take one example first. Here we have slinky. We push it forward and back and then again push forward and back. The energy is transported from one end to another end. So we draw this in here. So in this, the wave moves from left to right. The disturbance moves in the same direction as the wave. The vibrating particles are in to and fro motion, which is like this, about their mean position. So, sound wave is the best example of longitudinal wave. So, in longitudinal wave, getting denser and then spreading out, then again getting denser and then spreading out. So that's the longitudinal wave in which particle moves along the direction of wave and the particle is in to and fro motion. So the area which is more denser is called compression and The area which is less denser than the average is called rarefaction. That is compression. So this is the diagram of longitudinal wave, in which particle vibrations are parallel to the direction of wave. Now we have the definition of transverse wave. Transverse waves are waves where the disturbance moves perpendicular to the direction of the wave. That means vibrating particles perpendicular to the direction of the wave. In this, the wave moves from left to right while the disturbance moves up and down. That means the vibration of the particle is up and down about their main position. So the movement of particle is perpendicular to the direction of the wave. Example: in ocean, the water waves where the water moves up and down as the wave passes through the ocean. In this diagram, the maximum up from the mean position is known as crest, and the maximum down from the mean position is known trough. Now we have the definition of longitudinal wave. Longitudinal waves are the waves where the disturbance moves in the same direction as the wave. That means the vibrating particles move parallel to the direction of the wave. In this wave, the vibrating particle is in to and fro motion. In this diagram, the wave moves from left to right. Here we have two regions. One region where particles are closely packed is called compression, and here the particles are not closely packed is called rarefaction. So in longitudinal wave, the particles are parallel to the direction of the wave. Here we have example of guitar. As sound waves propagate through a medium, the molecules to collide with each other in the same direction as the sound is moving. So in longitudinal wave, particles vibrate parallel to the direction of the wave. Now we have the definition of sound wave. Sound wave is made when air molecules vibrate and move in a pattern. It is a longitudinal wave produced by a vibrating source. That means the disturbance moves in the same direction as the wave, and the vibrating particles are in to and fro motion. Examples of vibrating source are well, whistle, vocal cords and drum. Here this is the diagram of longitudinal wave, because sound wave is the best example of longitudinal wave. Here we have the three mediums which require sound wave to travel from one location to another location. So one medium is solid, in which particles are closely packed to one another. And next is liquid, in which particles are not so closely packed as compared to solid. Gases, the molecules are loosely packed. That means the gap between them is very large. Sound wave travels different speed depending upon what medium we give them. Here we have three medium: solid, liquid and gas. Sound wave travel the fastest through solid because the molecules in solid are closely packed. They are packed very tightly. And sound wave travels the faster through liquids. And in gases, the sound wave travels the slowest in them because the gap present between them is very large. Sound waves are travel in all direction but away from the source. Here we have musical instrument which produces sound. So sound waves moves away from the source. It not move in the direction of source. So sound waves are travel in all direction but away from them. The sound that we hear around us is the type of energy made by the vibrations. These vibrations travel through air or any other medium and can be heard when it reaches our ear. So basically, sound plays an important role in our daily life. You can hear many types of sound, which are female sound, male sound or baby sound in our surroundings. Let us discuss the characteristics of sound wave in detail. These characteristics are wavelength, amplitude, frequency, time period and velocity. First is wavelength, the distance between the center of two consecutive rarefactions or compression. That means the minimum distance in which a sound wave repeats itself is called wavelength. Here we have wave in which the distance between two crusts is its wavelength. Similarly, the distance between two troughs is its wavelength, and the distance between one complete wave is also its wavelength. Here we have two waves in this figure. First is longitudinal wave and second transverse wave. In longitudinal wave we have two regions, one is compression, another is rarefaction. In compression, in which particles are closely packed, and in rarefaction, here in which particles are far from each other. So the distance between two consecutive compression is its wavelength, and similarly the distance between two consecutive rarefaction is its wavelength. Similarly, for transverse wave, the distance between two crusts is its wavelength, and the distance between two troughs is its wavelength. Wavelength is represented by lambda and its SI unit is meter. Next is amplitude. It is defined as the maximum displacement of the particles the sound wave disturbs as it passes through a medium. In simple words, it is the distance between the mean position and the extreme position. Here we have wave which moves from left to right. That is its mean position and that is its extreme position. So when a wave passes through a medium, the particles of the medium get displaced from their mean position, and maximum displacement of particle from its mean position is the amplitude of the wave. So this is the amplitude of the wave. Here we have wave which move from left to right. In this, that is its amplitude. Which is large. So sound which it produces is loud because of more height of its amplitude. And in this we have also wave which is moved from left to right, but sound is feeble because of amplitude is small, because of low height. So maximum displacement of particle from mean position to its extreme position is the amplitude of the wave. Amplitude is represented with A and its SI unit is meter. Next is frequency. It refers to the number of sound waves a sound produces per second. In simple words, number of waves passing in 1 second. Here we have wave which move from left to right. So in 1 second, one complete wave is passing through it. Wave frequency is high or low. Here we have wave which move from left to right. So that is its wavelength and that is its amplitude. So in this, frequency is high, and here that is its wavelength and that is its amplitude. So in this, frequency is low. The main difference in both diagram is that because in 1 second in this diagram more number of waves is passing, and in this in 1 second less number of waves is passing. So here when the number of waves in passing 1 second is more is its high frequency, and when the number of waves passing in 1 second is low, then we have low frequency. The symbol of frequency is F or mu, and its SI unit is Hertz. Time period. It is the time required to produce a single complete wave or cycle. Here we have diagram in which waves move from left to right. So let's say point T. So wave, when it required to pass through that given point, so that is its time period. So basically, time required by one wave to pass through any given point is its time period. Its symbol is T. Its SI unit is second. Next is velocity. It is the amount of distance in meters per second that a wave travels in 1 second. In simple words, distance covered by wave in 1 second. So velocity which is equals to distance upon time. Here we have diagram, that is its wavelength in complete wave cycle, and that is its amplitude. So that is its velocity. So distance covered by the wave in 1 second is its wave velocity. So its symbol is V. SI unit is meter per second because distance is meter and time measured in second. So velocity is equals to meter per second, and its formula is V, which is equals to frequency into wavelength, which we use in numericals. Now we have to derive wave velocity's formula. We know speed which is equals to distance upon time. Wave velocity is distance covered by the wave in per second. So speed we write it as distance multiplied by 1 upon time. In sound wave, distance is equals to wavelength, which is between two crests, and similarly which is between two troughs, and which is between a complete wave cycle. So that is its distance. And frequency is 1 upon time. Thus we put the value of distance and frequency in this formula. We get speed which is equals to wavelength into frequency. So we write speed in V and wavelength with lambda and frequency with f. So we get this relation, which is V, which is equals to lambda into f, which is wavelength into frequency. Here we have some examples of sound wave. A light wave travels through a medium which has wavelength 600 nanometer. Determine its frequency. Given wavelength which is equals to 600 nanometer. We know velocity of light which is equals to 3 multiplied by 10 raised to power 8 meter per second. We know wave velocity's formula which is equals to wavelength into frequency. So we represent wavelength with lambda and frequency with f. So from here we get the formula of frequency, which is equals to V upon lambda. So put the values of wavelength and velocity of light in this formula. So f is equals to 3 multiplied by 10 raised to power 8 upon 600 multiplied by 10 raised to power minus 19. So f is 5 multiplied by 10 raised to power 14 Hertz. Thus the frequency of light wave is 5 multiplied by 10 raised to power 14 Hertz. Next one is sound wave has the frequency of 220 Hz and the speed is 440 meter per second in a given medium. So given frequency which we represent as f is equals to 220 Hz and speed of sound wave which is v is equals to 440 meter per second. We know the space formula which is equals to lambda into f, which is wavelength and frequency. So from here we get the value of lambda, which is wavelength, is equals to b upon f, which is velocity upon frequency. So put the values of frequency and speed of sound wave in wavelength formula, which is equals to 440 upon 220. So we get wavelength which is 2 meter. Therefore, the wavelength of sound wave is 2 meter in that medium. Next is a person is listening to a tone of 500 Hz sitting at a distance of 450 meter from the source of the sound. What is the time interval between successive compression from the source? Given frequency f, which is equals to 500 Hz. We know time period, which is equals to 1 upon frequency. That means 1 upon f. So put the value of frequency in this formula. We get t is equals to 1 upon 500. So time interval between the successive compression from the source is 0.002 seconds. We come across different types of sound and we are well equipped with the mechanism to understand different types of vibrations in the sound pattern. In our life, our father, our mother, siblings, our friends, or even every person has a different voice. Did you ever notice why every person has a different voice? To understand this concept, we learn about the properties of sound. Properties of sound. Since sound is a wave, so we can relate the properties of sound to the properties of a wave. The basic properties of sound are loudness, pitch and quality. Here we have diagram of sound A, sound B and sound C. Here sound B has a lower pitch than sound A because of lower frequency of sound B. And similarly sound B is softer than sound C because of smaller amplitude. Here amplitude is higher than sound B. So to understand this concept briefly, we further discuss loudness, pitch, quality in detail. First we have pitch. Pitch is a measure of high or low the tone of a sound wave. It is related to frequency. That means frequency determines the shrillness or the fluttering of a sound. That means high the frequency, high the pitch of a sound. That means it is said that the sound is shrilling. Similarly, lower the frequency, we get lower the pitch. So we can say that it is the sound that is fluttering. To understand this, let's take an example. Here we have wave which moves from left to right. That is its mean position and that is its extreme position. Here we have high frequencies and the gap between two waves is very small. So when the gap between the two waves is small, so we get higher frequency. That means when frequency is high, pitch is also high. So we can say that when higher the frequency, pitch is also high. So we can say that the sound is shrilling because the gap between two waves is very small. So this is the example of high pitch sound. And next is low pitch sound. Here we have wave which moves from left to right. So in this, that is its mean position and that is its extreme position. So here frequency is lower because the gap between two waves is very high. So we can say that when we have low frequency, the pitch is also low. So it is said that the sound is flattering. That means when frequency is low, pitch is also low. That means the sound is flattering when the gap between two waves is very high. So this is the example of low pitch sound. The example of high pitch is dog's bark, fire alarm and smoke alarm. Similarly, the examples of low pitch are drum, flute and trumpet. So it is easy to explain that in high pitch the gap between two waves is very small, so we get the higher frequency. So because of high frequency we get high pitch, so the sound produced is shrilling. Similarly, when the gap between two waves is high, so the frequency is lower and the sound produced is flattering because of low pitch. So this is the diagram of high pitch and low pitch. Next is loudness. Loudness is the response of ear to the sound. It is related to the amplitude. That means loudness is proportional to the square of the amplitude of the vibrating body producing sound. Higher the amplitude, loud sound we get, and similarly lower amplitude, feeble sound produced. That means in loud sound more the amplitude of the vibration, and in feeble sound lesser the amplitude of the vibration. To understand this, let's take an example. Here we have wave which moves from left to right. That is its mean position and that is its extreme position. So distance between mean position and extreme position is the amplitude. So that is its amplitude. So when the high amplitude of the wave, the loud sound is produced. Higher amplitude, sound is loud. So we can say that more the amplitude of the vibration, the sound produced is loud. And similarly for feeble sound, here we have wave which moves from left to right. That is its mean position and that is its extreme position. So distance between mean position and to extreme position is the amplitude of the wave. So lower the amplitude we get feeble sound. Here that is the amplitude. So we can say that here the amplitude is low, which is the height of the wave is very low. So when low amplitude of the wave we get feeble sound. That means lesser the amplitude of the vibrations, the sound produced is feeble. Loudness is measured in decibel. The example of loud sound is which produced through hammer and nail. And similarly the example of feeble sound is playing guitar. So In this example, we have more the amplitude of the vibration, so the sound produced is loud. And in feeble sound, lesser the amplitude of the vibrations, the sound produced is feeble. So we can say that in loudness we have two types. First is loud sound and second is feeble sound. So in loud sound we have more the amplitude of the vibrations. That means the height of the wave from to mean position is high, then we get loud sound. And similarly for feeble sound, lower the vibrations of amplitude, the sound is feeble. That means lower the height from the mean positions of the wave is, then we get feeble sound. Next is quality. Quality describes those characteristics of sound which allow the ear to distinguish sounds which have the same pitch and loudness. That means even if the sounds of two objects have same frequency and similar amplitude but emitted by two different instruments. Here we have example, the sound produced by guitar and sitar both have same frequency. That means both have same pitch and loudness, which is amplitude. But still we can easily distinguish between the sound of sitar and guitar without looking at the instruments, because we know the quality, the difference of both the sounds of these instruments. Here that is the sound wave of sitar and that is the sound wave of guitar. Both the sound wave produced by instruments have same frequency and same loudness, that means same pitch and same amplitude, but still we can easily distinguish the difference between both of them. That means by hearing the sound we can easily distinguish which instrument is playing. Different types of sound. There are two types of sound, audible sound and inaudible sound. Here we have definitions of inaudible sound and audible sound. First, we study about audible sound. Audible sounds are the sounds that the human ear can detect. That means the human ear can hear. The human ear hears the frequency between 20 Hz to 20 kHz. The human ear cannot hear the frequency above 20 kHz. And similarly, the human ear cannot hear the frequency below 20 Hz. So, but inaudible sounds are the sounds that the human ear cannot detect. That means the frequency below 20 Hz and the frequency above 20 kHz. It is further divided into two parts. First is infrasonic sound, second is ultrasonic sound. First is infrasonic sound. Any sound with the frequency below 20 Hz is known as infrasonic sound. That means frequency less than 20 Hz is known as infrasonic sound. And the examples of infrasonic sound are whale, rhinos and giraffe. They can hear the frequency below 20 Hz. Next is ultrasonic sound. Any sound with the frequency above 20 kHz is known as the ultrasonic sound. So, the frequency above 20 kHz is known as ultrasonic sound. The examples of ultrasonic sounds are bat, dolphin and dog. They can hear the frequency above 20 kHz. So these are ultrasonic sounds are the examples. Next is pleasant sound. Pleasant sound can be defined as a sound which is feel happy. That means that sound when we hear give us happiness, which relax our mood. So examples of pleasant sound can be the sound of river flowing, butterfly sound, sound of word like cuckoo, etc. So these examples are the examples of pleasant sound which give us happiness when we hear that sound. Here we have example of butterfly sound, and this is the example of sound of cuckoo which give us happiness, pleasure. Next is unpleasant sounds. Unpleasant sounds can be defined as the sound which irritate us and can cause headache. That means that sound which not give us happiness and we not feel relaxed by hearing that sound. So that sound is unpleasant sound. Here we have examples of unpleasant sound. Can be the sound of construction site, horn of train and other vehicles, and rock music, etc. These examples of unpleasant sound which does not give us happiness, that not relax our mind, these sound only irritate us. So these are the examples of unpleasant sound. Here horn of train and rock music are the examples of unpleasant. So friends, what is reflection of light? The bouncing back of light when it strikes through a plane mirror is called reflection of light, in which we have two angles, angle of incidence and angle of reflection. And the angle of incidence is equal to angle of reflection. So just like the reflection of light, we have reflection of sound. When sound travels in a given medium, it strikes the surface of another medium and bouncing back in some other direction. This phenomena is called reflection of sound. And the waves are called incident wave and another is reflected sound wave. Here we have example. Sound produced by observer comes in this direction and strikes through this hard surface and bouncing back in this direction. So when sound travel in this medium and strike this surface and then reflected back in another direction is called reflection of sound. And this wave which comes from the observer is called incidence wave, and which wave is reflected back is called reflected wave. So to understand this in detail, we take an example. Here we have example in which this is the hard surface and this is the sound comes from the observer, and when it strikes through this hard surface it bouncing back in this direction, and this wave which comes from the observer is called incident wave, and this wave which it reflected through in this direction is called reflected wave, and this is the normal and this is the angle of incidence, and this is the angle of reflection, and this is the hard surface. So the bouncing back of sound when it strikes through the hard surface is called reflection of sound, in which angle of incidence is equals to angle of reflection. And one more thing, the angle of incidence, the angle of reflection and normal all lie in one plane. So this is the example of reflection of sound. Now the two laws concerned with sound reflection are as follows. The incidence angle will always be equal to the reflection angle, and the incidence sound wave, the normal at incident point and the reflected wave all rest in a common plane. That means all lie in one plane. Here this is the light which comes from the observer. That light which comes from the observer is called incidence wave, and when this light bouncing back in this direction is called reflected wave, and this is the angle of incidence which make with the normal, and this is the angle of reflection which make with the normal. So the bouncing back of sound when it strikes this hard surface is called reflection of sound, and these are the two laws of reflection of sound. Now we have uses of reflection of sound. Reflection of sound is used in many devices. For example, echo, stethoscope, soundboard, loudspeaker, megaphone and hearing aid. So now we discuss all these in detail. First we have echo. It is the sound heard when reflections occur from a firm surface. This surface may be wall, a cliff and many other. That means echo is that sound जब आप किसी भी पहाड़ी पे जाते हो, किसी अकेले रूम में हो और अपना नेम जोर से चिल्ला रहे हो, देन जब आप चुप हो जाते हो आपको वही आवाज़ फिर से सुनाई देती है. That sound is echo. So echo is the repetitions of sound even after the source has stopped vibrating. That means जब अपना नेम लेने के बाद चुप कर जाते हो आपको वही आवाज़ फिर से कानों में पड़ती है. That sound is echo. Thus repetitions of sound occur because of multiple reflections of sound wave. Here we have diagram. In this is the sensor and this is the target. So from sensor sound wave is produced, and when it strikes through this target it bounces back. So that sound is echo. And echo is used by bats as well as dolphins for the detection of obstacles. Now we have stethoscope. It is used to hear the sounds of internal organs of a patient for a diagnostic purposes, which works on the law of reflection of sound. In this, sound is received by chest piece. This is the chest piece and sent to the earth by multiple reflection through a long tube. To understand this, let's take an example. It consists of long tube, this one, which made up of rubber and metal. When sound pulses pass through from one end to the tube, the pulse is concentrated to other end due to several reflections in the inner surface of the tube. Here, sound pulses pass through one end to another end. So, due to this multiple reflections through a tube, sound is heard through the earth pieces. And the next is soundboard. It is used to send the sound towards audience in big hall or auditorium. It is a big concave board. That soundboard works on the basis of reflection of sound. Soundboard is set in such manner behind the stage that speakers is at the focus here. So sound coming from the speaker falls over soundboard and get reflected towards the audience. Due to this large gap between the audience and the stage, audience can hear everything very clearly because of soundboard. This is the diagram of soundboard. And the next is loudspeaker. It is used to send the sound in a desired direction without spreading the sound all around. That means इसका यूज हम साउंड को एक पर्टिकुलर डायरेक्शन में सेंड करने के लिए करते हैं. It acts on the laws of reflection of sound wave. In this, a funnel-like cone-shaped tube is used like this. Sound is introduced at this narrow end of the tube. This is the narrow end. And sound is to come from its wire end. So here we have diagram. This is the funnel-like cone-shaped tube and sound is introduced this narrow end and sound come out from this wider end. Next is megaphones. Megaphones are horn-shaped tubes that prevent the spreading out of sound wave. That means it's not spread the waves in all directions. Waves of sound are spread in a particular direction by successive reflections, thus confining them to the air in the tube. So a cone-shaped device for magnifying the voice used in addressing a large audience or crowd out of doors or calling to someone at a distance. That means मेगाफोन का यूज हम क्राउडी एरियाज पे करते हैं जब हमने किसी पर्टिकुलर पर्सन को बुलाना हो. The next is hearing aid. Hearing aid is a device used by people with difficulty in hearing. That means hearing aid का हम वहाँ पे यूज़ करते हैं दिस डिवाइस का उन लोगों के लिए जिन लोगों को सुनने में प्रॉब्लम होती है, जिन्हें कम सुनाई देता है. Here the sound waves are received by hearing aid and reflected in a narrow area leading to the ear. Next we have reverberation. To understand this, first we understand this diagram. This is the auditorium in which sound is produced. Because sound is produced, so due to reflection of sound, echoes are produced. Here sound is go to the listener direct, and here multiple echoes are built up. So these echoes easily decay because they are absorbed by the furniture, people, air, curtain, etc. So it is the phenomena of persistence of sound after it has been stopped. That means it decays gradually as a result of multiple reflection from surfaces such as furniture, people, air, etc. within a closed surface. That means जो sound की वजह से echo produce होती है वो echo gradually decay हो जाती है. किसकी वजह से? Because furniture, people, air, curtain उस echo को easily absorb कर लेते हैं. So that is the reverberation. Next we have example. A person clapped his hands near a cliff and heard the echo after 5 seconds. So what is the distance of the cliff from a person if the speed of the sound is taken 346 meter per second? So given speed of sound, which is v, is equals to 346 meter per second. Time taken for hearing the echo, which is t, is equals to 5 seconds. So distance travelled by the sound, which is equals to velocity time. So put the value of velocity and time, we get 346 meter per second into 5 seconds, which is equals to 1730 meter. So in 5 seconds, sound has to travel twice the distance between the cliff and the person. So distance between the cliff and the person is equals to 1730 meter divided by 2. So we get distance between the cliff and the person is 865 meter. Now we have next example. An echo return in 3 seconds. What is the distance of the reflecting surface from the source given that the speed of sound is 342 meter per second? Given speed of sound is equals to 342 meter per second. Echo returns time, which is equals to 3 seconds. So distance travelled by sound, which is equals to v cross t. So put the value of speed of sound and echo returns in time, we get 342 multiplied by 3, which is equals to 126 meter. We know sound must travel a distance which is twice the distance of reflecting surface and source, which is equals to 126 upon 2. So we get 513 meter. Thus, the distance of reflecting surface from the source is 513 meter. Next, we have sonar, which full form is sound navigation and ranging. It is a device that uses ultrasonic waves to measure the distance, the direction, and the speed of underwater objects. एक ऐसा डिवाइस है जिसमें हम अल्ट्रासोनिक वेव्स को यूज़ करते हैं, किसके लिए? डिस्टेंस पता करने के लिए, डायरेक्शन पता करने के लिए, और अंडर वाटर जो ऑब्जेक्ट चलते हैं उनकी स्पीड को मेजर करने के लिए. Now its principle is it uses the phenomena of echoes in determining the sea depth and locating the presence of underwater objects. Here we have diagram. This is the ship. This is the transmitter which transmits the wave, and this is the receiver which receives the wave. So the phenomena of echo is based in this. The sound waves are emitted from the transmitter, then by striking this object it bounces back and come back to the receiver. The receiver receives these waves. So by using this we easily determine the presence of underwater objects and the depth of sea in the sea. The working of sonar. A sound beam of ultrasonic wave is sent from a transistor mounted on the ship. That means जो शिप के नीचे ट्रांजिस्टर लगा होता है उससे हम क्या करते हैं, वेव्स को ट्रांसमिट करते हैं by using ultrasonic waves. Then the beam is reflected from the ship and is received by the underwater detector which is also mounted on the ship. And then जो हमने वेव्स सेंड की है, जो ट्रांसमीटर ने वेव्स कम आउट की है अपने में से, वो वेव्स जो किसी ऑब्जेक्ट के साथ स्ट्राइक करती हैं, here the waves come out from transistor and bouncing back, then reflector reflects these waves. So the time interval between the transmission and reception of the ultrasonic signal is noted. So this is the working of sonar, in which we have two main parts. First is transmitter and another is receiver. Transmitter transmits the wave and receiver receives the ultrasonic waves which come out from the object. Now we have example. A submarine emits a sonar pulse which returns from an underwater cliff is 1.02 seconds if the speed of the sound in salt water is 1531 meter per second. So how far away is the cliff? Given sonar pulse taken time to return is equals to 1.02 seconds. Speed of sound in salt water which is equals to 1531 meter per second. So distance traveled by sonar pulse, which is equals to S into T. So put the value of sonar pulse and the speed of sound in this formula. 1531 into 1.02, we get 1561.62 meter, which is the distance traveled by the sonar pulse. So distance of cliff from the submarine is equals to total distance upon time, which is equals to 1561.62 divided by 2. So we get distance of cliff from the submarine is equals to 780.81 meter. Now we have structure of human ear. It has three parts: outer ear, middle ear and inner ear. First is outer ear, which collects sound from surrounding. तो क्या करता है, हमारे आसपास से साउंड को कलेक्ट करता है. And the next is middle ear. It amplifies the vibrations. तो वाइब्रेशन को amplified करता है. And the inner ear convert sound into electrical signal. And this is the diagram of human ear, which has many parts: pinna, eardrum, ear canal, hammer, anvil, stereo, cochlea, semicircular canal, auditory nerve. So these are the important parts of our ear through which we can hear everything. By using these parts, we can hear everything around us. So let's study in detail. First we have pinna. It is the outer ear. It acts like a funnel to send the sound waves inside the ear. That means ये एक funnel की तरह काम करता है. साउंड वेव जहाँ से आती है और इसके अंदर चली जाती है, लाइक दिस, यहाँ से अंदर चली जाती है. ओके. एंड द नेक्स्ट इज ईयर कैनल. साउंड ट्रेवल्स फ्रॉम द आउटसाइड थ्रू ईयर कैनल. दैट मीन्स जो पिन्ना से साउंड आया, देन वो ईयर कैनल के थ्रू आगे चला जाता है. देन जो साउंड ईयर कैनल से आया वो ईयर ड्रम से ईयर ड्रम तक पहुंच जाता है. That means the sound then falls on the eardrum, which is at the end of the canal. Next we have three important bones of our ear: hammer, anvil and stirrup. These bones, then the sound waves are then passed on to these bones in the middle ear. That means sound waves, by using these bones, sound wave हमारे कानों तक पहुंचती है. Okay. The next is cochlea. The sound waves are converted to electrical signal by using cochlea. Cochlea के थ्रू जो साउंड वेव्स हमारे कानों तक पहुंची है, एंटर हुई है, वो किस में कन्वर्ट हो जाती है? इलेक्ट्रिकल सिग्नल्स में. एंड द नेक्स्ट इज ऑडिटरी नर्व. ऑडिटरी नर्व क्या करती है? सिग्नल्स को हमारे ब्रेन तक पहुंचती है. देन उन सिग्नल्स को हमारा ब्रेन इंटरप्ट करता है, एंड देन हाउ वी हियर, देन हम सुन पाते हैं. सो दिस इज द स्ट्रक्चर ऑफ ह्यूमन ईयर. So I hope friends you like my video. So thank you for watching my video. Like my video and subscribe my channel, and also share with your friends.